What's up, scholars? Today we're talking about factoring the sum and difference of cubes. So, before we get into that, let's talk about some common cubes. Like 1 cubed is 1. That means 1 times 1 times 1. 2 cubed means 2 times 2 times 2. That's equal to 2 times 2 times 2, which is 8. That's right, my favorite one. Favorite cube right there. Love it. 3 cubed, 3 times 3 times 3 is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343. These are the common ones. These are the ones that are going to show up the most. So let's just smash those into our noodle noggins. Let's do some practice rewriting things as sums or differences. Sum meaning that we're going to add some stuff, difference meaning we are subtracting some stuff of cubes. So let's use this table and rewrite these 3 expressions as sums or differences of cubes. 27 is what cubed? It's 3 cubed. 3 cubed. 64 is 4 cubed. This is plus because there's a plus in the middle. 4, and then x cubed is x cubed. Okay, so 4x cubed would give us 64x cubed. How about 216? 216 was 6 cubed. And we've got our x here, so this is going to be 6x cubed. Minus 1 is 1 cubed. So that's a difference of cubes. And then 343x cubed. 343 is 7. So we've got 7x cubed plus 8. 8 is 2 cubed, and y cubed must be y cubed. All right, not too bad. We've got some rules here for factoring sums and differences of cubes. A sum of cubes is going to factor to a plus b times a squared minus ab plus b squared. And a difference of cubes is going to be a minus b times a squared plus ab plus b squared. This trinomial here in both of these parts will never be factorable. So the trinomial is never factorable. So in a lot of ways, the difference of cubes are pretty easy, because it's just a one-stepper. Once you figure out that something is a sum or a difference of cubes, that's not going to be factorable, because that's there's no GCF here. And then the trinomial will never be factorable. So let's look at some examples. Oh wait, hold on, there's something with stars here. There's a short memorization toward of these formulas on the test. I have to memorize these things. Yes, it's going to be fine. It's going to be totally fine. Sum of cubes. The first factor is a plus, and the second sign here is minus. Difference of cubes. The first factor is a minus, and both of these are pluses. However you want to make that make sense to yourself, maybe you just write it out 1,000 times until it's smashed into your noodle noggin. You will have to memorize these parts, or these formulas, for the test. Why, you ask? Why would we ask you to memorize things when you never need to memorize things in the real world? Because the SAT doesn't give you these formulas. So we're going to make you practice them now, so when you take the SAT, they're just already in your brain. Okay. Is the SAT real life? Of course not. Is the SAT going to be a gatekeeper for you to go to Institute of Higher Learning? Yes. Yes, it is. So, we're trying to help you figure out how to memorize some stuff that you're going to need for that test. That's what that is. Yeah. All right, let's look at some examples. 40 minus 5t cubed. 40 and 5 were not on the table of cubes. Oh, but we could take a greatest common factor out first. What's our GCF here? We could take out a 5, and then we get 8 minus t cubed. That is now a difference of cubes. This is 2 cubed minus t cubed. So the a is 2 and the b is t. So this will become our GCF in the front. 5 times, okay, this is a difference of cubes, so we're using the second formula. 2 minus t times our a squared. A is 2. 2 squared is 4. Minus, nope, plus a times b plus 2 times t is 2t plus b squared. B is t squared. That's it. That wasn't bad at all. Remember, that trinomial, never factorable. So we're done. How about this sucker? Do we have a greatest common factor? By golly, we do. Let's take out a 3. Let's also take out an x. We'll be left with 8x cubed plus y cubed. Now this is a sum of cubes, because this is really 2x cubed plus y cubed. So our a is 2x and our b is y. It's a sum of cubes, so we're using the first formula here. So we'll have 3x times a plus b, 2x plus y, times a squared. 2x squared is 4x squared, minus ab, 2x times y is 2xy, plus b squared. B is y, so plus y squared. And that's as good as we can do. There you go. All right. Next one. Do we have a greatest common factor? No. Okay, so this is supposed to be something cubed minus something else cubed. 64 was what cubed? That was 4 cubed. How do I get x to the 6 out of something cubed? What do we remember about our exponent powers? If we have a power 2, a power multiply. So this must have been x squared, because 2 times 3 is 6. So this must be 4x squared cubed to get to 64x to the 6th. Minus, again, what's going to go in here? It's going to be y to the 2nd power, because y squared cubed gives us back that y to the 6th. So this is the difference of cubes, which factored to what? A cubed minus b cubed factored to a minus b times a squared plus ab plus b squared. Okay. So our a is 4x squared and our b is y. So this is going to become 4x squared plus y squared times, why did I put a plus there? It's a minus. Minus, it's a minus. Definitely a minus. It's supposed to be a minus. All right, cool. A squared. A is 4x squared. If I squared 4x squared. 4 squared is 16. X squared squared is x to the 4th. So this is 16x to the 4th. Plus a times b, 4x squared times y. Sorry, my video cut out there at the end. So, we had 4x squared minus y squared. Our a squared, our 4x squared squared is 16x to the 4th. A times b is going to be 4x squared times y squared. And b squared is going to be y squared squared, which will be y to the 4th. That's how we get that final answer. Again, that trinomial is never factorable, so you're all done. You're going to do the next one, and we're going to finish off with everybody's favorite, the crazy things that have only letters. What in the dickens? We can do this. We can do this. If you factor x cubed minus 8 in the form x plus a times x squared minus bx plus c, what's the value of a? Okay, well, this looks like a difference of squares. I mean, difference of cubes. So, x cubed minus 8 would factor, because it's a difference of cubes, x cubed minus 2 cubed. That would factor to, using the same formula up here at the top, which I can't seem to put both of those things in the same. I'll just rewrite it. Let's just rewrite it. Good practice. This is going to be a minus b times a squared plus ab plus b squared. My a here is x, my b here is 2, so this is going to be x minus 2 times x squared plus 2x plus 4, right? Okay, so this is x minus 2 times x squared plus bx plus c, or b must be 2, or c must be 4. What's our a value? This says minus 2. This says it's supposed to be plus a. So a must be minus 2. A must be minus 2. That wasn't as bad as I thought. Okay, got it. Cool. All right, what did we talk about? We talked about common cubes. My favorite of all, 2 cubed is 8. Love it. Love it so much. We practiced rewriting expressions as sums or differences of cubes. We were given these formulas to factor sums and difference of cubes, which smarter people than I figured out a long, long time ago. And I like to beg, borrow, and steal from the smarter folks. We noted that the trinomial in each of these cases is never factorable. I dropped a bomb on you that said you're going to have to memorize these formulas for your test. Ah! Gonna be fine, though. Gonna be fine. We did some factoring. We remembered to take out greatest common factors first before we did anything else. We even did it when it had x's and y's, but that was totally fine. And my video cut out, and you still did a great job here, coming up with that good stuff. This is easy peasy lemon squeezy, y'all. That's it, scholars. Love you so much. Keep on the hustle, and I'll see you next time.